Hello guys, so it's Patro TV here. I'm just gonna show you a quick video of how you can set up your plotting on Chia. So just make sure you download the latest version of Chia if you're just starting off. So when you press Windows, so you have to go and just go on Google and search Chia download, and then you just go into chia.net. Install Chia blockchain, and that way you click Windows, macOS, Ubuntu. Ubuntu and macOS apparently is 10% faster, not using the UI interface, which means the graphical user interface, like buttons and stuff like that. But I don't think personally it makes much of a difference. I use Windows and I've been doing just fine. So I have been doing Chia. Oh, let me just change it to English. I've been doing Chia plotting, 7 plots at the same time, and it's doing very well. So just to show you, you go to Windows, you download it, and everything on here, just follow the steps and install the basically a blockchain wallet. You will start off on this screen. You can create a new one. Just make sure you save those words. Don't lose your wallet. That's the most important thing. You don't want to lose it. You go onto your wallet. Now we're just loading up the wallet. I'm gonna keep the video unedited without any cuts, so you can have a clear view of what's happening. There we go. So we are on here. We're connected. So for plotting, what you want to do essentially, when let's say my setup is, if we go on here, I have 32 gigs of RAM. Okay, I have, you can see, 6 cores and 12 threads. It's so on here you have 12 threads. That's what you're going to be assigning to the plots. And I've got 980 Evo here, which does all of the work. As you can see, it's not hitting 100%. If you have a cheap SSD that is like 550 megabytes read and write, you'll notice that it will peak most of the time. So it's only recommended if you have a faster drive for this plotting, because parallel plotting does require a lot of speed. There are times where I peak at 1.4 gigabytes. Of course, if you want to have a fast plotting speed as me, I would recommend running on PCI-E 4 and basically the M.2 NVMe drive. So what basically PCI-E is the latest connection. I'm gonna keep it short. If you have a like B550 board or one of the latest, just Google the specification of it, of your board, and see if it has PCIe 4 or what's the top speed it supports. So just to add the plot like normal, you just go on your plots. Okay, you add the plot, and what you want to start off is, when you do plotting, let's say we look at the drives. So I have 2 terabyte drive. So if you go to calculator, what you need to do is, most importantly, calculate the temporary space. Of course, I have 7 plots running, and it doesn't use all of the space. I could add another one, but there is a risk. So take a look at this. So let's say I want to run 7 plots. So 7 plots times the temporary space, which is 239, equals 1673 gigabytes. Of course, it's less than 1.8 terabytes. The only thing you have to remember is that if you add one more plot, 239, it all goes over 1912. Of course, 1.8 terabytes is very close to this number, and the likelihood that it will go over that number is very unlikely. But let's just assume that one of your plots froze, okay, because it can't write. That means all of your plots will freeze. So all of my 7 plots would freeze, and they would not make any progress because there isn't any free space. That's why you have to prevent that. Essentially, that's the best way of doing it, not overloading the SSD. I'm happy with 7. I could add 8, but if you look at my CPU, it's already peaking at 100%, and I get each plot every 1 hour and 30 minutes. So I'm happy with the result. I don't want to jam in another plot because it can mess things up, and I don't want to restart, because if I did restart, look how many percentages I would lose. I probably would lose 3 plots worth of work. So the thing we do first, so let's get back to adding plot. So when you, let's say, wanted to set up 7 plots, so I would say calculate on 1 terabyte. I actually have tried it, so let's go for 1 terabyte. If you have a 1 terabyte, you would have around 956, I think, gigabytes, or 920, I can't remember for sure. So if you times that by 4, you have 956. So you'll be short a few gigabytes. I think on a formatted drive you have 920. So you'll be 30 gigabytes short. The only thing you have to remember, if you're gonna start in parallel 4 and 0 delay, you will hit the full capacity of your solid state and you will freeze. So what you can do is calculate, let's say, how long it takes for your machine to do, let's say, 1 plot or 2 plots at the same time. Let's say the way I normally do it, the way I calculate, let's say, it's a bit really weird, the way I calculate it, but it works. It just works. Where's the slider? There's no slider. Okay, so let's go back to the phase 1 on here. So you can see that this part, this table, took me 1700 seconds. So 1700 seconds divided by 60, that will turn it into minutes. So that's one table. It's best if we go to phase 1. Where's the phase 1? Let's keep on moving me back. Okay, let's just scroll up this way. And that's not even in that hasn't even completed phase 1. So let's just go up this one. So this one has completed phase 1, because phase 1 is up to 31%. So if you wanted to know how long is the phase 1 lasts 31%, and then it starts phase 2, which is doing the new tables. So the phase 1 took me 1100 seconds. So if we calculate that into minutes, divide by 60, that again by 60, so we have it in minutes, so that took me 3 hours. So let's just assume that the time for phase 2 was 612. So let's do 612 divided by 60 divided by 60, so 1.5 hours. So I had 3.5 there, so that's just 3.6 is 5 hours. And then we've got, and I have phase 3 and phase 4. So let's have a look at phase 3. So we calculate it. That's what this is doing in parallel. Have a look if I can find phase 3, if it will let me. Starting phase 3. I think phase 3 is just writing onto the phase 4 is just writing onto the hard drive. First computing pass, compressing the tables. Can't seem to find it, which I'm not sure. Anyway, so let's just assume the phase, 2 more phases will take twice as much, so times it by 2. This is quite accurate for me because that's how long it takes. So if you times it, it's roughly 10 hours and 30 minutes that it takes. So that's how I look at it. So to do plot, it takes 10 hours and 30 minutes. So if you do 10 hours and 30 minutes, okay, and how many plots you want to do, the speed doesn't change much between plots. If you, let's say, you're running, what's this example? let's say if you're running only 2 plots, you might be able to do it in 9 hours, okay? It really all depends on your CPU and how good it is. If you have a quad-core CPU, an i5, you might be able to do only 2 plots, you see. Even if you have a 2 terabyte SSD, I have a i5 6400 on my mining rig, and I tried doing 2 plots and I was struggling. So what I would recommend, maybe getting a 6-core processor or Ryzen processor, but if you have an Intel, just stick with what you have, but don't overload your CPU. My one isn't always at 100%. That's what you want to prevent, because otherwise all of the plots is gonna be slow. So after 31%, it's gonna whiz through, and all of them will end up at the beginning at phase 1 at one point, and it's gonna go extremely slow. So just imagine having 7 plots at phase 1 where it uses all of the CPU power. So CPU power is mainly used under 31%. So let's go back to the ad plotting. We're adding 6 plots, so we want to make sure that's in parallel. So we're doing 85 delay because I want to run 7 plots, okay, over a course of 10.5 hours. But I did it for 10 hours, the calculation. So 10 hours times 60, so that will give me in minutes time, divided by 7, which is 85, okay? So in 10 hours, I want to do 7 plots. Okay, if you wanted, for example, if your rig is slower, you would have to calculate in the plots how long your computer is able to do it. So for example, if you know you can do 2 plots in 14 hours, okay? So what you can do is, okay, if I have 2 plots, I'm pretty sure I can do 4. Then you do 4 plots divided by 14. Oh wait, that's wrong. So yeah, 4 plots. Sorry, 14 times that by 60. So you gain minutes because you need to put in the minor minutes. Okay, divided by 4 plots. Okay, that's your delay. Times that by 60, so you have rough. Oh, not times that divided by 60. You know, every 3.5 hours you're gonna have a new plot started. So at the time, because what you want to prevent, you don't want too many of them running at the phase 1 as well. You don't want them all running at the same time, because once it reaches the 100%, it will start writing onto the external hard drive, and it will actually freeze up, slow down the whole process. You could run it on each individual drive, but then it's just too much work, too messy. Because I could just fill up one drive this way, you know, in each one at a time, and then once my drive is full, then I can just add another drive to the queue, just add a plot, add to the plot queue, and these 7 basically, let's call them threads, 7 threads for the plots will continuously start and follow the queue. I don't have to mess around with it, making it parallel. It's just simpler like this. So to set this up, for example, let's start off simple. You have 920 gigabytes and you want to run 4 plots. You can run 4 plots on the terabyte drive. I wouldn't recommend running 8 plots on a 2 terabyte drive because there is a risk of something hanging. Your CPU might not even keep up, or your drive that's writing it may be slower than expected. You have to take these things into consideration, because if it goes down, your whole time you invested into this, it will be wasted, and you have to restart again. Like if my plotter crashed, I would lose 3 plots technically. So if you do plot in parallel, then you set up the delay. My one would be 85. Of course, if you have been running a plot before, you know roughly how it works. The only one more thing that you have to consider mainly is the RAM. So if you have a RAM, let's say 32 gigabytes, you can easily run 8 or 7. Say 7 times 3,800. That's 26.6. So roughly it would be like 25 gigabytes, an estimate. The reason why I set it to 3800 because it will show us 3.55 gigabytes. So if we go to the processors, at the moment doesn't show, but the normal usage is around 3.5 gigabytes, and some of the buckets, they have a size of 3.5 gigabytes, but you won't be doing those if your RAM size is below 3.5. So that's why I set it to 3800, because it will make the buckets a little bit larger. And I don't know, I did it once that I set it to 3200, 32,000, and I saw some buckets being bigger than the usual, like 2 or 1.5 gigabytes. That's why I set it to 3800, so it does those buckets that are 3.5 gigabytes. I think it's just better processing, because when you have, let's say, 2 plots, you'll notice those gaps. That's the time where your CPU is not being used. So anyway, going back to these plots, so you set 6 in parallel, and that will start every 85 minutes. Then once you set this up, so let's say default, I set it to the number of cores that I have, so 12. I mean the threads, logical processors, that's your threads. Cores is number of cores, so I set it to 12, and I leave it as this. I set it temporary, and we do the drive. I want to fill this one in, and I have a folder called plots, and that's pretty much it. And then you just start it. Once you start it, you will notice that it will start plotting with one of them, and after that you want to make a 7th one, so 7th plot. The 7th plot, to do it, you will have to add a plot to queue. So actually create a queue, because at the moment you have 7 plots working, 6 plots working in parallel, but you don't have a queue. So this actually creates the queue and starts the first plot in the queue. So that way you will have 7 running. And you do it exactly the same as for the other one. And that's pretty much it. So you just set a temporary drive and plots. The only thing I would recommend, because when I was setting it up, I did lots of mistakes. Sometimes in a temporary directory, I set my hard drive as my plotter. I would always recommend you to count how many things you need to change. So like 1, 2, 3. If you're doing this continuously, so you need to change 3 things. You have queue names. You can name it that. I just keep it as default. It's easier because I know I calculate. Okay, my drive has 3.8 terabytes. You can take let's say 37 plots, because if I put 38, it isn't even number, so it could go over, and that's why we want to prevent time wasted. So let's say 37 plots. And that's pretty much it. Once you start it, you have 2 plots running. So let's make this, I'll show you on another screen. Oh, where's my computer? It's not showing. Okay, let me just restart my rig. My PC just crashed. I have another computer, but it's not plotting. I can show you guys. If you want to skip off the video, you can do. I'm just gonna start like a plotter on my other machine, so you can see how it works on another machine. But if it's helpful for you to set it up like calculation wise, then leave a like. So if you're interested on how I'm gonna set it up for my other computer, then stick around so I can show you. So this is Parsec. Parsec is a free software. It's mainly used to play games, but what I use it for, I sign in on another computers, and I can access them remotely. You can even game on your computer remotely if you've got a shitty laptop and you want to start it on another machine. So let's go on here. And this is there. I don't know if you can see this. You can see it, yeah. So this is my mining rig. Something crashed. I'm not sure why, because it's not farming at full potential, the 6800. But anyway, let's go on the Chia. I don't even have a hard drive plugged into it, so, and it's in Polish. Okay, so I don't even have space to plot on it, but we're just gonna make a quick setup so you can have a look. So farm, well, it's English. Farm, add plot. The way you would do it, you plot in parallel. Of course you won't start because I only have 8 gigabytes. So just make sure you have enough RAM, especially for the 1 terabyte users. You need to have minimum 16 gigabytes to run 4 plots. So I'll show you what will happen. So parallel and the temporary drive. Just make that. It's gonna be a mess, but we're starting that, and then we start another one, same directory. Doesn't matter. And you will notice that it's plotting as well. And then when you add another one to the same queue, okay, it's queued. That's what you want to do. When you do, let's say 3 plots, and then the 4th one is gonna be from the queue. Okay, sorry for the loud noises. That's pretty much it to set it up for 2 terabytes and 1 terabyte drives, and we'll see how we get on with it. Thank you very much for watching, and I hope this helped you somehow. If you have any questions on this and you need some more instructions or more clear information, then just let me know down in the comments. And one more thing, the RAM speed actually does matter. So the faster the RAM, the faster the SSD and the RAM processes it, because then it will go faster to the SSD and etc. The slower the RAM, then of course it will slow down the whole process. Yeah, so that's it, and thank you very much for watching.